Hi, my name is Ilona Söchting, and I want to welcome you to explore how optical measurement technology and satellite data can be used within forestry and the wood industry. Along with experts at the University of Vaasa and Adopticum, we're on a mission to help companies throughout the whole value chain increase their competitiveness and their value by the use of these technologies. We are a highly diverse team with both men and women from different backgrounds in different countries. This diversity puts us in a great position to help you identify new innovative solutions and stimulate new ways of working towards both sustainability and equality. In this video, my colleagues Greger and Ilona will give you a crash course in both optical measurement technology and satellite data. You will get familiar with what this is, how it works, and most importantly, how it can strengthen your business. Perhaps you can enhance your current services or products, or maybe develop completely new ones. Maybe you'll find that you can attract and recruit new types of talents by changing the way you get the job done. Either way, we're here to help you explore these technologies and inspire you to find the solutions that suit your particular needs. Our hopes are that by watching this video, you will find some inspiration and a curiosity to want to learn even more. So watch it with your colleagues and have a brainstorming session and try to think about what types of applications could be relevant for you. Try to think about the challenges that you experience in both your everyday activities and your long-term strategies. Now it's time for me to hand over to the experts. So enjoy.
Hey, and welcome to Adopticum. This is going to be a short introduction to optical measurement technology. I'm going to talk a little bit about the technology, and we're going to give you some examples of applications. The main purpose is really to inspire you to think about how this could apply to the work that you do in your organization. So first of all, what do we mean when we say optical measurement technology? We talk about this all the time. Well, basically, it means to measure things by the use of light. So remember, there is visible light, but there's also ultraviolet light and infrared light that is invisible to humans. Optical measurement technology is part of a broader field, which is called non-contact sensing. The great thing about it is that you can measure things quickly from a distance and without affecting the object or process that you're measuring. Another way you can think about it is that optical measurement is really about digitalization of real-world objects. There are many different types of cameras and sensors used in optical measurement. Let's look at a few common camera types just to give you an idea of what they can see. This first example is a multispectral camera. That means that this camera can see a few extra colors or wavelengths of infrared light. By processing the image and applying false color, we can visualize properties that are otherwise invisible to our eyes. This type of camera is commonly used in agriculture and in forestry to identify plant species, to monitor photosynthesis, and also for early detection of disease in plants. If we go even further away from the visible light and into the long-wave infrared, there are thermal cameras that can see the temperature of objects. These cameras have gotten a lot better and a lot cheaper than they used to be, making them more accessible to more applications. Another type of camera is the depth camera, which is also called a 3D camera or a distance measuring camera. These work in a few different ways, but they all produce an image where you get the distance from the camera to an object in each pixel. In the example here, I'm holding up a white piece of paper in front of a white wall, and this is difficult to see with a normal camera. The image on the right is from a depth camera, and it's easy to separate the paper from the wall because it's closer to the camera. Here, false color is used to show distance. So green means about 150 centimeters and red is about 60 centimeters from the camera. Depth cameras can typically capture about 30 to 60 3D images per second, and they are best for shorter distances of less than 10 meters. LiDAR is a way to measure distance by using pulses of laser light. These work by scanning their surroundings using one or multiple laser beams at the same time. The advantage that they have over depth cameras is that they can measure hundreds of meters and also maintain their accuracy over long distances. Right now, there's a transition going on from mechanical scanning to solid-state technology. This enables small and robust LiDARs that are lower cost and fit for high volume production. The demands from the automobile industry is driving this development. This new generation of LiDAR is opening up many new possible uses for the technology. My last example is normal visible light cameras. These are used in all kinds of vision applications. The cameras are of course getting better, but the revolution here is in the image processing. Machine learning and deep learning has changed how computers can extract information from images. I think the important thing for companies to know here is that today there are plenty of products, tools, and frameworks available. You don't have to start from scratch. Tech companies have done the groundwork, so you can build your vision applications by using their tools. Okay, those were a few examples of camera types. Let's now take more of a bird's eye view on the topic. If we were to make a generalized diagram of every optical measurement system, it would look something like this. It always starts with light. And this can be general light that's already available in the environment, but it could also be light from the measurement system itself, perhaps a laser. The light is reflected by the object that we want to measure, and there are some kind of optics to gather the light and project it onto a sensor. The sensor, together with the electronics, converts the light into an image or a signal. And after that, it's all about what the software can do with this information. In the end, we get some form of measurement result. Okay, let's take this example. If this was a vision system, perhaps it could tell us what type of tree this is. Or if we capture it in 3D, maybe we could get some dimensions of the tree. Or if this was a multispectral camera, maybe it could tell us something about the health of this tree. These are all examples of measurement results, but this is really only half the story. The question is, how do we create value from these measurements? In this next section, I want to give you a few examples of different ways you can create value. One way to create value is by immediate feedback of results to control the process. Automated, objective, and repeatable results can help you improve quality and also to reduce waste of time or resources. A second way to create value is by traceability. If you record the measurements together with the identity of the object, then you can trace the object back through your process. Sometimes it's even possible to trace the object through its entire lifespan. Third, statistics. When you measure thousands of objects, you can track changes over time, generate reports, or show key performance values. I'm sure there are people at your company that aren't very interested in measurements of individual objects, but they do want to see numbers on how things are going. My last example of value takes this one step further. You can start to think about data as a resource in itself. Data science is a tool to extract new knowledge from data. If you ever want to go towards artificial intelligence or deep learning, then you're going to need lots of data and good data. Think about the systems that you already have that are producing data. Is there perhaps valuable data that you aren't using? Also, when you commission new systems, think about who owns this data and make sure that you have the right and the access to use this data any way that you want, because this isn't always the case. Okay, let's now switch to some examples of projects and applications. And to do that, we will look at some local companies that we have worked with recently. Lundqvist Trävaru is a company that some of you may be familiar with, especially if you've looked at building a summer house or a garage. Lundqvist has developed a tool that lets the customer build their house in 3D on their website with easy-to-use tools. You start by selecting the dimensions, you place doors and windows, select materials and so on. The prices update as you go and you see the total. And in the end, you order the house as a kit. This is an example of innovation by using modern technology. The product isn't new, it's a house, but they sell it in a new way. The process is completely digital and highly automated. We did a project with Lundqvist Trävaru in late 2018. They wanted to explore the possibility of using augmented reality to visualize a house before you order it. So you would go onto your plot and use your phone or tablet, and then you can place your house virtually. You can walk around your house and see it in 3D, what it looks like, and see how it fits in with existing buildings. It was still a little bit early with augmented reality on phones at the time, especially for objects of this scale. But it basically worked, and I hope we will see this feature in the future. This example is from a production line in a factory right before these assembled parts go in for paint. Painting is done by robots, so it's very important that the right part is sent in. If you send in the wrong part, not only will it be painted in the wrong color, and that will increase waste, but worse than that, the robot or the sprayer might collide with the part and cause expensive damage and repair time on the paint station. This system is based on a consumer-grade depth camera to capture these parts in 3D right before they go in for paint. The software is able to tell which model it is based on its shape and its features. If it's the wrong model, then the line is stopped. And as you can see, they look very similar and are easy to mix up. The value created here is the automated measurement and feedback to the existing process. This reduces waste and avoids expensive mistakes. This is not a system that takes precise measurements, but it also doesn't need to be. This example is from a sawmill. In the picture, you see a conveyor that feeds logs into the sorting station. Normally, the logs go in one by one, but sometimes 2 logs can go on the conveyor at the same time, and this is a problem. In this project, the goal was to detect double feeding of logs by using available, inexpensive industrial sensors. Here, 2 or 3 single-point laser distance meters are used for sensing. There's a little bit of software to process the data, and then a signal is delivered to the control station. The value created here is simply feedback to the control process. So this is an example of a simple solution to improve safety and efficiency in an existing process. Okay, so now it's time to summarize this introduction into optical measurement technology. We started by showing you some examples of cameras and sensor types. We've talked about how to create value from measurements, and we've shown you a few examples of applications in industry. Right now, there's a rapid development in technical capability, both on the sensor side, but even more so on the software and data processing. The cost of hardware is coming down, and in some cases, like LiDAR, for example, quite dramatically. There are lots of products and tools available on the market to build upon and to create solutions. All this combined means that there is a lot of opportunity to turn ideas into reality. Our mission is to help companies in our region to make use of optical measurement technology through new products or process improvements. There are a number of different ways that we can do that. You are very welcome to contact us with any questions that you may have. Lastly, I want to encourage you to think about how this applies to your work. What are some of the challenges or opportunities at your company? We're looking forward to having a discussion with you on these topics. Thank you for your time, and here is Ilona, who will talk about satellite technology.
Hello, my name is Dr. Ilona Söchting from the University of Vaasa in Finland, and I would like to show you today how satellite technologies are rapidly reshaping the business landscape. We hope that this brief presentation will inspire you to start thinking about the possibilities of satellite data in your business. Over the decades, the space industry has moved a long way from being just big science to becoming a big business. Satellite navigation, satellite communications, and satellite Earth observations stand behind many modern-day applications, their contribution often staying unnoticed by the end users. For example, position and navigation using mobile phone is powered by satellite signals from the Global Navigational Satellite System, the same one as utilized for monitoring of airplanes and shipping routes. We have autonomous cars and tractors and even drones utilizing satellite signals for navigation. Satellite Earth observations, referred often as remote sensing, are used for our protection, to monitor forest fires, oil spills, air and water quality, to name just a few. It is a fast-growing segment, thanks to novel sensing technologies becoming available, but also due to growing number of ready-to-use global and free data repositories with exciting derivative data products. Remote sensing comprises lots of different technologies, and it definitely doesn't mean just pretty pictures. Satellites can actually see and sense far beyond the visible light, both in passive and active manner, allowing us to utilize different wavelengths to detect, classify, and visualize different areas and materials. Depending on the business challenge, satellite data can often provide fast and reliable answers very economically, particularly in combination with other technologies. Satellite-enabled insights are becoming increasingly the drivers for new business opportunities and models. The commercial utilization of satellite data is supported by a competitive and reliable supply chain, providing exploration-ready data products that, supported by mature academic sector, helping businesses in development of real-life solutions, led to explosion of end-user applications and broad integration of satellite data into daily business operations. At the University of Vaasa, we have a large research team dedicated to problem solving using satellite data, with access to technical and financial resources for the most relevant use cases from the forestry industry. We are always on the lookout for new challenges and are keen to learn about yours too. Thus, please don't hesitate to contact us if you would like to learn more. A critical contribution of satellite technologies is the global coverage. The global information availability has a profound impact on our world. Obviously, it has enabled scientific research on unprecedented scales and added to transparency of human activity. From the commercial perspective, it has enabled completely new ways of doing business. Open access to global data means that companies can use big data approaches without actually owning or collecting big data themselves. It changes the status quo, allowing even small and local companies to initiate global expansion. Global satellite data helps to find in what environments current customers or products operate, and consecutively ask critical questions like, are there similar viable markets into which the company could be operating in the future? How will global warming and changes in land use change current markets? How will the changes in conditions in which current products or factories operate impact their technical requirements? There are lots of possibilities, and we have a lot of data. What we need are good use cases, inspiring novel solutions. The true power of global big data unfolds when combined with small data, which is very business or use case specific. We can identify patterns in well-understood local data and find their counterparts in global on global scales. Common use case for satellite data is the monitoring of land usage and classification of land, which is a typical example for remote sensing. At the top of the slide, we have a good example of detecting changes. We can see the effects of deforestation and the new roads. Below, we have an example of classification of land usage based on Sentinel-2 data. The whole Earth has been classified based on land usage. Remote sensing is a good way to very economically monitor large areas. Therefore, it is often used in detecting and estimating damages in forests caused by insects, pests, strong winds, forest fires, or flooding. For example, insurance companies are utilizing remote sensing. The big question is if satellite data could help us foresee these damages, allowing us to prevent them in the first place. In data-driven forest management, satellite data can be utilized to estimate the value, state, and type of the forest with many attributes, like, for example, above-ground biomass, mean tree height, mean stem volume, and many more. It is possible to calculate the carbon stock and make prediction models. This will be an important topic, as, for example, Finland is aiming to become carbon neutral by 2035 and it is very valuable to try to estimate effects of global warming. Other hot topic is the development of virtual forests, which can be used as a decision support tool. Also, for a forest owner or a forest company, the gathered data, together with predictive models, can aid investment decisions. Satellite data can be used to improve forest logistics. By monitoring forest roads and soil conditions, we can see the areas which do not support the heavy forest machinery. Very practical example is the monitoring of the forest machines and their conditions and having the positions of the logs, which can be used for traceability and for certification purposes. How could global data support your business? We hope that our video was insightful and hope to have encouraged you to meet us and discuss how the optical measurement technology and satellite data could help you. Thank you.
So, now that you've gotten some insight into what optical measurement technology and satellite data is, we want to invite you to come meet our experts and continue exploring how you can develop these ideas into pilots, prototypes, or other initiatives. Feel free to share this video with anyone you think might find this interesting, and please get in touch with us. Thank you very much for watching, and we hope to see you soon.